Okay, so R should never be negative. So the hypotenuse, hypotenuse, I'm having issues today. Oh my gosh, hypotenuse will never be negative, so we're going to put a little R, never negative, okay? The other two can be negative because it depends on where we're going in the quadrant. Okay? And let's just put that around here. All right. So now we've established that is 5. I start finding my trig values. Okay. So I'm looking at my angle theta. So theta is the angle formed with the x-axis. Remember yesterday we talked about reference angles? So let's put like a little underline thing, x-axis. Not the y-axis, the x-axis. So the opposite of that angle is -4. So when I set up the trig expressions, -4 over +5 or -5? What's it say right here? R is never negative. You got a little something in there. Okay, so cosine is adjacent. So that's also -3/4. So -3/4. Now tangent is opposite, which is -4 over -3. But of course, we're not going to leave it like that. Why not? The negative divided by negative is a positive. And then I'm going to work my way back up around. So take the reciprocal of each. So if that's 4/3, this is 3/4. If this is -3/4, secant is -4/3. And if sine is -4/5, then cosecant is -5/4. Pause and wait for y'all to get caught up. I'll take any questions. We're just going to rewrite these. So instead of using words, we're using symbols. Again, mathematics is a universal language, so we don't use the words because then that might confuse somebody from a different country. So sine y, because if you look at the previous page, my y value was opposite the angle. And then x is touching it, so that's the adjacent. So this is going to be y over r. This is going to be x over r. Opposite over adjacent, so opposite's y over x. And then these are all just reciprocals on the right. So x over y, and r over x. And last but not least, r over y. Okay, we're going to use those from now on instead of OPP, ADG, and HYP when we are graphing on a set of axes. All right. So using that idea, let's see what you can do on your own with this one. Okay. So find the sine, cosine, and tangent, cosecant, secant, cotangent. But the first thing you're going to find is that hypotenuse. You go do that. So we've set up the picture, and the picture is important. Okay. It should be oriented so that the angle, remember we're looking at this angle right here. Tiny thin little thing between the x-axis and the hypotenuse. That is what we call theta. Okay. So 6 squared plus 2 squared is 40. When I take the square root of 40, that is not a perfect square. So I need to break it down. So 40 equals r squared. Square root of 40 equals r. I wish they had the same shortcut that Desmos did. That would be so nice. Maybe in the future. I shall send Henji an email. Henji's the CEO.
Where's Henji from?
New Zealand. Actually spoke to him. Okay. Henji Wing or Wang, one or the other. Wang. All right. R equals. What's a perfect square that divides into 40? 4. So square root of 4 times the square root of 10, but the square root of 4 is 2. So R is equal to 2 square root 10. Okay? At this point, put that on our little equation right here. We can copy and paste. I do not like typing in square roots. That's another thing. They should have the cursor inside the square root after you type it. Another note to Henji. Oh, look at that. Whee! I selected it, but I did not copy it. Control C. Control B. Okay. So 2 squared root of 10. So when I make my sign, opposite is 2 divided by 2 squared root of 10. Can that be simplified? Oh, yeah, because the 2's divide out. I'm just going to have 1 over square root of 10. Now, there are some teachers that would make you simplify at this point. I am not one of them. I will talk about how you could simplify that later. We've talked about it a little bit before. Yes, ma'am?
Why is it 2?
Why is what 2?
2 over 2 on the first one.
Okay, so opposite or the y value over the hypotenuse. Okay, and the hypotenuse length is 2 squared root of 10. Okay, so cosine is adjacent or the x value. Come on now. Negative 6 divided by the square root 2 squared root of 10. Can you divide 6 by 2? Yeah. So this one's going to be negative 3 divided by the square root of 10. Okay, let's move this over here a little bit. Okay, tangent is just a 2 over negative 6, but of course we're not going to leave it that way either. Negative 1/3. So negative 2, 6 is the same as negative 1/3. So take a moment and flip those to get your cotangent, secant, and secant. Secant and cosecant. Questions on cotangent, secant, and cosecant. Just take these and flip them. That's all you're doing. Okay. Let's skip that one. Let's do that one. Okay. So plot 4 and 7, and then find your hypotenuse and find your 6 trig values. Make sure your answers are in simplified form.
Are we not breaking it down?
We don't have to break anything down because, well, we break it down, it's 5 and 13. Either is a perfect square, so there's nothing to do with it. Okay. So fraction bar, so 7 divided by square root of 65. I'm just going to copy and paste the rest of these because I'm going to have lots of 65s in here. Instead of rewriting it every single time, copy, paste, and then my x over 4 over square root of 65, and then 7/4, and that can't be simplified because 4 doesn't go into 7. And then notice, I don't go up to cosecant, I just kind of go this way because I just did the last one, so it's fresh in my brain. You can do them in any order that you like. This is going to be square root of 65. Just make sure you're outside the square root before you divide by 4. And square root of 65 divided by 7. Okay? Give you a minute to get caught up. And then the next page, we're kind of working backwards. You're going to be given the trig ratios, and we have to find the values on the triangle. Now the question is, which quadrant do I put these in? First. So, I'm going 3 up, and if my hypotenuse is 5, didn't I say there's a special right triangle? What's a special right triangle that has 3 and 5 in it? A 3, 4, 5 triangle. Okay? You can prove it with Pythagorean theorem. 5 squared minus 3 squared. That's 25 minus 9 is 16, and the square root of 16 is 4. Wake up, Ahmad! There you go. All right. So, I am plotting the point 3, I'm sorry, 4/3. So cosine is going to be 4/5. So I go 1, 2, 3, 4 to the right, 1, 2, 3 up because sine is up. I'm going to make my line from here to here. Don't hold the shift key down this time. That's not such a good one. Let's pick a different color. That's so much better. Nice and contrasty. So what's tangent going to be if this is 3 and this is 4 and this is 5? Okay, 3/4, right? Guess what? That's only half the answer, okay? Because I didn't give you a critical piece of information. I didn't tell you that it had to be in a specific quadrant. You just assumed. Okay? What other quadrant can I have a positive 3 in for my y value?
4.
So we have another triangle to draw, okay? I'm going to get super fancy. Ready? Right triangle. I'm just trying to make a mirror image of this one. So instead of positive 4, it's negative 4. This is still positive 3 and this is still 5, which means my cosine doesn't necessarily have to be positive 4/5, does it? It could be positive or negative. And tangent could be positive 3/4 or negative. So unless you are given specific information as to which quadrant you're supposed to draw your triangle in, you could have two answers. Okay? So just look at the information. If somewhere it says given that cosine sine theta equals 3/5 and is located in quadrant 1 specifically or quadrant 2 specifically, then that would restrict what your answer is. Okay?
They can never be like diagonals with the triangle itself.
They could, but I'm only going to give you, if you're given added information, you're only going to be given one at a time, or one quadrant at a time. Okay? All right. You have boatloads of time. You have almost a half an hour. What should you get done first? 1 and 2.